Welcome back. I'm Sean Smith, visual media developer at Kaarta. In the previous video, we did a brief overview of all the features of the new visualization tool. In this video, I'd like to go through each one of those individually, show you what they do, and give you a few pointers along the way. So let's dive in. Okay, let's get started with the appearance panel. The first thing you'll notice is the point budget slider, which goes from 100,000 points to 10 million points. Now, this basically acts like a performance filter, rendering more points closer to the camera. On desktop computers, you can set this as high as it goes, but on mobile devices, you may want it a little bit lower, especially if you're dealing with larger point clouds for performance reasons. Now, the next slider we have is the field of view, which works much like a cinematic camera. And as the value gets higher, so does the perspective distortion. Setting this high might be useful for tight interior spaces where you want to be able to view more of the area, fit more data into the camera view. The next thing we'll cover is iDome lighting, which, if you're familiar with Cloud Compare, is a tool that's built into there to simulate light hitting the point cloud. This filter will allow us to control the radius and the strength of that iDome lighting filter. Setting the radius higher will create a larger outline around each point, whereas the strength will work by darkening the points from the back away from the camera closer to the camera as you increase the slider. I don't usually like to use this on colorized clouds, but it's very helpful if you have something that's sorted by elevation or intensity only to bring out the details of the objects versus having it off where you can't really tell where the tree starts and ends. Background options you have are Skybox, which creates this nice realistic looking sky. So if you have some kind of scan in the real world, this might be a useful display option for you. The one that's default is the gradient, which is just a really dark gradient background. And then we have our black, white, and none. And the only difference between none and white is if you're using an EDL filter, the points that are in front of the foreground will not have the EDL filter applied to them, whereas if you choose the white background, you'll notice right away that even the points that are against that background are getting the EDL filter, but on the none, they do not. And then the other option we have is splat quality. Now, if you have your point cloud set to do round points, you won't really notice a change because the only thing this does is changes it to rounded points. So that's a quick way to change from squares to rounded points. The minimum node size down here, this slider, will actually control the point size on a macro scale, whereas later on we'll discuss changing this point size down here. It kind of is a factor or multiplier of this point size. So you can get them really big or really small, but the higher the minimum point size is, the bigger this adjustment will be down here on the point size. The next thing you'll see is the box, which is actually the octrees and how it broke down this file. So we can click that on to view all those octrees and click it to turn it off. We also have the lock view toggle down here, but that one is still in development, but it will lock the camera view when you check it so that you can't accidentally move that if you're trying to do some measurements or gather some data. All right, let's take a look at the tools panel now. As a general rule of thumb, most of the measurement tools here will work by allowing you to place 2 or more points with the left click, and then you have to right click to end the placement. So once you decide to place these measurements down, it will lock the camera view into place. So make sure that you're in a good spot where you can get all your measurements. I think the only thing you could do is zoom out while you're placing these points. So let's get started. The first one's the angle measurement, and it'll look for 3 clicks. You got to do 3 points, and it'll give you a measurement of all the angles in between those. Anywhere on the ground, I can place these angles, and it will give me the measurements of each of them. Just note that it's really kind of finicky about how you place the points, so you want to zoom in on the map and make sure they're where you want them to be. And then after you place them, you can zoom the camera around. If we want to check this out, we can go down into our object hierarchy and select that measurement, and it will give us the properties and the details. Also, if we want to delete any of these measurements, there's a nice little red X in the properties, and that'll delete this specific measurement. Up at the top, there's an X under the measurement options. That'll delete all of your measurements on the scene, so you want to be really careful about touching that. If you have a lot of measurements on there, you don't want to lose. We don't currently have the ability to save these out, but we are working on adding that feature. So the next measurement tool is just the point tool, and this will give you a measurement of any point on the map. So you can click anything, and that's basically all it does, give you an XYZ value. So let's take a look at the next one. That's your distance measurement tool. I zoomed out a little bit so that I could kind of get a bigger range. We can kind of measure this street. We'll use 4 points, and then I'll right click to stop it. That'll give us each segment measurement, and what it'll also do is sum those measurements for me. So here we can see each for the 4 points that I put down, the distances of each of those, and then also the total of those. All right, the next measurement is height. And what this does, it's an interesting tool because it will show you the actual vertical straight measurement in this dashed line here. If you're not exactly on center, it'll let you know where you need to be to place that. So after you place these objects also, these measurements, you can move them around. So you can get your camera in place so you can better measure that. So after you place these measurements, you can move them and drag them around also. And clicking on our height measurement down the properties basically shows us what we know on screen. All right, the next tool we have is the area measurement tool, and this is very cool. So you can easily click around an object on points only. It won't work if you're clicking in empty space somewhere out here. It'll only snap to the points, but you can get a rough idea of an area here just by clicking a few points. And the cool thing is there, it sums it for you and gives you the XYZ of all those points that it uses. And you can do more than 4 points. You can do 10 points. As big as your scan is, you can measure areas of that. Another cool tool is the cubic measurement, which isn't really good on this scan. But if we wanted to get maybe a volume measurement of one of these buildings, say, we could kind of roughly estimate how big it is by moving this box. It gives us this 3D gizmo that we can use these dots, these circles, to size it. And we can also use the rotational gimbals here to change the rotation of that box. And the cool thing is too, is if we go into our properties for this volume measurement, it can also become a clipping volume. And we'll discuss those in a little bit, but basically if you select this on, it's gonna highlight the points that it's selecting, which is useful for seeing what exactly is inside that box. And then if we want to clip those points out, we can do that very easily with our clipping tools here. Moving on, we have our height profile. This is a really awesome tool. If you click down this street, we can get a height profile of the entire thing. And you can scroll to zoom out a little bit, but you can't really move the camera while you're placing these points. Start here, we'll place 1 point here and 1 point down here. And I'll only do 2 points, but you can do more if you'd like. And then the cool thing about this is if you go into your measurement hierarchy here, select the profile, you get your X, Y's, and Z's. You get a width that you can determine how thick that point is, how many points it'll bring in, which is useful if you're exporting this, which you can do by clicking this 2D profile button here. And that'll actually bring up a two-dimensional plot of those points you selected so you can see the height ramp. It'll give you information wherever your cursor is about the intensity and the color. And then also what's neat is these buttons up here will allow you to export these points that are in the height profile into a LAS or CSV file. So that wraps it up for our measurement tools. What I'm going to do now is click this red X. That'll delete everything. But keep in mind, if you just wanted to delete one, it's a red X inside its properties for each one of those. We can also turn them off with the checkbox so they won't display on the screen, but they'll still be there. Moving on to our clipping tools. Before I get started showing you what those tools do, I want to discuss what the clipping tasks and the clipping methods actually do. So clipping tasks are labeled according to what they do. None will do nothing. It won't highlight it and it won't clip anything. So if that's selected, you won't notice your clipping volumes actually doing anything. The highlight clip task method is going to highlight the points that are going to be within that clipping area so that you can point out areas of interest or tell what points are going to be clipped before you actually clip them. Now, the inside clipping task will only clip the points outside of the clip boundaries. It will keep everything that's on the inside of that clipping boundary. Whereas the outside clipping task does the opposite. It will remove the points inside that boundary and show only the points that are outside that boundary. Now, for the clipping methods, this only is affected by having more than one clipping volume in the scene at one time. What it does is inside any means any point that's inside a clipping boundary will be able to be used. If you have inside all, it will only clip the points that are inside all of the boundaries in that scene. So if I had 2 volume measurements and they were overlapping, it would show me only the part that's overlapped. So we can take a look at that here in a second. So I will place a volume clipping boundary down here on my scene. And you'll notice it's the exact same thing as our volume measurement tool. And we looked at those properties, and this already has the make clip volume selected. So that's the only difference between those two tools. It is the same thing. It's just one has the clip volume selected. And now if I place that, let's say clip inside, and I'm going to set it to inside all. Now, and notice it doesn't do anything because there's only one clipping volume. But if I add a clipping volume down here, let's say, when I have inside all selected, you won't see anything until those two bounding boxes overlap. And that's what that clip method inside all does. I'm going to use this X. It will clear all of my clipping boundaries on the screen, and I can start fresh. So you should be familiar with that volume clipping measurement tool, where I can set the height and the width of the box, and I have my gizmos that allow me to rotate it. This is one of the more straightforward tools. It's good if you're trying to get like a large area clipped. You can kind of straighten things out. There's a button on the properties of this object that will reset the orientation, so it'll kind of straighten it up if you accidentally rotate it or something. It will put those back to 0 on the rotation. The next tool we have is the polygonal clipping tool. The polygonal clipping tool allows you to just select up to 8 points to create this clipping boundary from, and it works based on the camera perspective. So if your camera is aligned a certain way, it kind of goes straight through like a ray casting. It will go straight through those points based on the angle of the camera. So what happens sometimes if we are on a side view, it can clip points that are behind the things that you don't see. So if I select this bounding box, it's actually going to clip all those points behind it as well. Add those to the clipping boundary. It works just like the measurement tools where you click to place and you right click to finish placing, but that tool can only handle up to 8 points. So if you're trying to make a really complex polygon, that's not going to work. The next tool is the orthographic clipping mode, and that will give you a little warning. If you're not in orthographic camera, it'll give you a little warning to say this tool only works there. So once we switch to our orthographic camera here, we can select this tool and it just draws out a box or a rectangle, and it'll clip the points that are within that. And they're adjustable. You can rotate those. It might be a little easier to use than the volume clipping tool for you, especially if you're in orthographic mode a lot. Moving on to our navigation tools. Before I get started with each one of these, I want to dive into the perspective and orthographic mode because that'll come up a lot in the next part of the video. Under the navigation options are the perspective and orthographic mode toggles, which you should be familiar with if you've used Cloud Compare or other 3D design software. I'll discuss this a lot in the next section of the video, so I wanted to mention them briefly here. A perspective projection will distort the objects in the camera, much like our eyes perceive objects, while the orthographic mode projects the data within the constraints of a grid without the distortion. It's tied into the field of view you'll notice won't work if you're in orthographic mode. Switching between the two is as easy as hitting this toggle, and you might notice one weird quirk is that when high quality splats are being used, the orthographic mode will not display very well. So you need to switch that splat quality to standard if you're going to be using orthographic mode. Now let's dig into the navigation tools. We're going to start on the left side at the top here with our Earth navigation control, our fly control, followed by helicopter control, orbit control, full extent, and navigation cube. Now the default behavior is the orbit control, where the left click will rotate the object and right click and drag will pan the object. Whereas the Earth navigation control will do the opposite of that. It will use left click for panning and the right click will be the rotation. We're going to skip the fly controls since those are still in development, and we're going to move right on to the full extent button. Now, if you're zoomed in on a cloud, you might want to get back out of that angle, and the full extent button is what you would use. It takes the camera's angle and just zooms you out, so it'll bring you back out of that cloud while keeping all the points within your viewport. So if I'm really zoomed in on something and I want to get out of there, I'll hit the full extent button and it'll give me that view from where I was based on the camera angle. The next view is the navigation cube, which if you've used an Autodesk product, you're familiar with this. If you click on any side of the cube, you will go to that view. And if you click and drag around on the cube, you'll be able to manipulate the point cloud by dragging that around. It works very similar to the controls underneath all these navigation options, which are your side and top and bottom and back and front views. You can click those buttons. It works the same way as the navigation cube, so you can use either one of those to easily navigate the scene, to get a side shot if you want to go into orthographic mode and get your profile views or whatever you want to do there. Another thing you'll notice is the speed slider here. It displays relative to the camera and the zooming, whatever camera projection method you're using. You won't need to touch this. It's determined automatically by the camera and navigation type. So you'll see it move as you zoom around the scene, but you do not need to touch it. The third and final panel is our scene panel, and this is the most important part of displaying your point clouds, where the customization options live. The scene panel also includes some export options, but those will only work for your measurements and clipping volumes. You can export those by clicking the button, selecting whether you want to use DXF or the JSON format. Now that brings us down to our object hierarchy, where we have point clouds, measurements, annotations, and other, which is where the camera lives. It works by showing the properties for each object when they're clicked. So the properties display below the hierarchy and have their own set of options depending on what object was selected. For measurements and the clipping volumes, you're able to see the details about the measurements for each point, as well as a total of all the points combined, depending on what option selected. For point clouds, this is really where the display customization comes into play. If you select a point cloud in the hierarchy, you're presented with a lot of options. So let's go through them and see what they do. The first thing you see here is the point size slider, which you can use to tweak the point size. This is relative to the min node size that we discussed earlier in the appearance panel. So if this isn't working, try increasing the min node size a little bit. It's a multiplier effect. So the bigger the min node size, the bigger the change in the point size will occur when you use this slider. The next option is the point sizing selector. We can pick from fixed, attenuated, or adaptive. The default is set to adaptive, and that means that the points will be sized based on how close they are to the camera or the octree that's being displayed. It should work fine for most users. If you want to select fixed point size, that means that the point size will stay the same no matter what the distance is from the camera, and they do not scale based on camera distance or any zooming. The attenuated option will scale points based on the distance from camera so that they stay the same size relatively no matter how far or close they are. The next option is shape. We have the choice between square, circle, and paraboloid. The square points are the default display option unless you have high quality splats set. But what that'll do is it'll make it render quicker. They're easier on the computer. If you're using a mobile device, I would say use the square setting to save resources. If you want it to look a little nicer, you can select the circle option, and that'll kind of round things out or smooth things out a little bit, but it will take up a little higher resources. You might notice your laptop fans kick on when you're using the circle shape to display your point clouds. And then the final shape is a paraboloid, which is a circular 3D object that produces some of the best results in most cases, but it also uses the highest amount of resources to render on the screen. Next, we have the opacity slider. And if you're using high quality splats, you need to turn them back down to standard in order for the opacity slider to work. And what this will do is change the opacity of each point so that they become see-through. Sometimes you'll notice that where there's a lot of points overlapping, it'll become super saturated or super bright. Because it's an additive blend mode, it will add to each other. In most cases, though, it works fairly well, especially for interiors. If you're trying to see around a building, it can create the effect of X-ray vision of being able to see through the walls. Whereas if the opacity is set to 100, you won't be able to see through other points as easily. All right, next up is our attribute selectors, and these will allow us to display the point cloud based on the various scalar fields that are within that LAS file. Some of these aren't converted correctly yet, so we're still in development there. The first half dozen here on the list will work, which is the RGB and elevation, color, elevation, intensity, and intensity gradient. Those are all selectable options. The other ones will return values, but they're not really hooked into the system yet. Starting with the RGB attribute, you can see below we have sliders to control the gamma, brightness, and contrast. Right now, the contrast isn't hooked in yet, but the gamma works much like an exposure adjuster, and the brightness can then brighten or darken the points on the colorized point clouds. The next attribute is RGB and elevation. That's a blend of the elevation mode where you can control, you see below you have your options for the elevation gradient selectors, where you can change that, and it just overlays on top of the RGB values, which can be helpful in some instances if you want to see the color and elevation together. The next options we have are just color, and so this is going to look like nothing until we turn on our EDL shader there. But what this does is allow you to select a single color, and then the point cloud will be displayed in that. It's useful if you're trying to create visual assets that are all in the same color scheme. Next up on the list is elevation, which this is not mixed with RGB, so that's your elevation view. And the neat thing is about this, it'll automatically detect the min and maximum range values. But if you want to change those, you can always adjust them based on maybe a clipping section, or you want to get some more detail out of it. As you can see, Lombard Street is pretty steep, so there's a big change in elevation there. You can change the gradient scheme here of the elevation from these preset gradients, and we'll be adding more to this list as well. But the interesting thing to note here is for the next one, intensity, it is going to choose from this elevation gradient. So if you want to view it, it's actually with intensity gradient, you can select those gradients in the elevation view, and it will select it when you go to choose intensity gradient. So I know we skipped intensity. That is displayed only as black and white, but you do have a range slider where you control what the intensity range is. And you also have your gamma, brightness, and contrast sliders there as well. And the final one, like we discussed earlier a minute ago, is the intensity gradient, which will display the intensity as a gradient rather than just black and white. And you have your sliders that you can adjust there. You'll notice the reflective street signs are giving a very high intensity value. Those will glow very bright. And then if we want to change the gradient that the intensity gradient is using, we have to go to elevation, and we'll change our scheme here to whatever we want, and then go back to intensity gradient, and you'll be able to see those results. All right, and that wraps up all the options you can do with your point clouds. There's one more object in the hierarchy, and that's the camera. And that basically will only show you the properties of the camera, where the position and the target where it's looking. So that wraps up the scene panel and the rest of the tools. And I hope you found the video informative. And we can't wait for you to be able to get started visualizing point clouds with Kaarta Cloud. This feature will be constantly improving as we tweak the visualization engine and the UI to offer the best possible experience for our Kaarta Cloud customers. Thank you for watching.